All right, here we go. In this section of engineering mechanics, we're going to solve our first moment problem in 3 dimensions. We have XYZ system, we have a pole sticking up, and then we have some kind of bar coming out along the X direction, and at the tip of the bar we have a force oriented this direction of 800 pounds pulling this way. Notice that the force is directed along a line, and we kind of give you some dimensions about where that intersects the plane down here, but we also give you the length of the bar, the height of this column. Everything is here in order for us to calculate the moment of this force acting about point O. So what we want to figure out is how much moment, or in other words, turning action or turning force, is this force induced about this direction. Now this problem would be difficult to do in terms of a scalar calculation because you would have to break this up into components and then you would have to have an R vector coming from here to this point that you would also have to break into components, and you would have to make sure that you are multiplying the proper component times the proper perpendicular distance, and then you would need to make sure and keep the signs of everything correct, because now, since this is not simply in the XY plane, some of the moments could actually be in the X direction, some can be in the Y direction, some can be in the Z direction. In other words, if you pull on this thing, the moment that's produced here, it's not going to be purely a rotation about X. It's definitely not going to be a pure rotation in Y, and it's not going to be a pure rotation in Z. And I've got the answer right here, and I can tell you that when you pull obliquely like this, that the rotation about point O is going to be a mixture of the rotation in the X direction, the Y direction, and the Z direction, because the thing is going to kind of be doing something weird like this. So it's definitely a place where you want to deal with doing this in vector calculation. Okay, so the first thing I want to do is we want to write down that the moment about this point is R cross F. All right, now what do we know about R? It always goes from the point of rotation to any point along the line of action. And for now, let's just do it just like we've been doing in the past. Let's take the R vector coming from the origin up to the tail of the force vector, or to the point of application. So what would be the vector starting at the origin, where the rotation point we're trying to figure out is, and terminating up here, okay? Well, what you really need to figure, since this is 0, 0, 0, the vector is going to terminate at the coordinates of this point right here. So what you really know is that the R vector, it's going to start at the origin, which is 0, 0, 0, and it's going to terminate here. So what are the coordinates of this point B right here? Well, we know the length of the bar along the X direction. Notice this bar sticks out 32.5 inches. This distance is only 27.5. So the bar actually sticks out far